I bid a good day to all you lovely people. So welcome to this video. If you like the video, hit the like button. If you want to comment, please do. If you'd like to ask any questions as well, just place it in the comment section. If you want to share this video, please do that. And if you want to subscribe, then please subscribe and you'll have access to all the other great videos that will be coming your way. With that being said, let's get on with it. Hi and welcome to the video. Now, let me see, what have we got lined up for you today that'll get the senses tingling? Aha, yes, of course, the MED attribute, another BGP attribute. Exciting, excitement all round. I can hear it in your voices, the gasps of delight. Okay, so let's get on with this presentation and then we can get on with the live demonstration for you. So this video is understanding and configuring the multi-exit discriminator, or as we call it, the MED in BGP. So again, it's an optimization for routing decision using MEDs for beginners to experts. So first of all, well, what is a multi-exit discriminator? What is the MED? Okay, well, it's a BGP attribute that helps select the best path to route data between autonomous systems. But remember, that's only localized between two systems. It's not multi-AS. It can't go across multi-ASs. Only localized between the two eBGPs, between those two ASs, whether that be an upstream or downstream autonomous system to another ISP. So the MED helps influence inbound traffic on multiple links. Okay, the lower the MED number, the higher the priority. And we configure a policy and export this via the BGP group to inform our BGP neighbor which entry point into our AS is preferred. Now, we do have an option to do an import as well. Now, that's dependent on what ASs you actually have control over, but we can go into that later as we go through this presentation and the live demonstration. So let's show you how that actually looks on the next slide. So let's have a quick look at how the multi-exit discriminator functions. So we'll have a look at the wide area network above, the topology. So we have traffic from the internet host on the right here that wants to communicate with the web server on the left. Now, if we leave all the BGP attributes as default, then the path decision process would go all the way to the lowest ID. And in this case, the path chosen would be via R1 from R3. The reasoning behind that is the RID is lower than the RID on R2. So R1's RID is lower than R2's. So it will choose that path. So if we want to influence the route from R3 so that it traverses R2 instead of R1, as we just showed, then we have to create a policy in this AS and export it into BGP that raises the MED number on R1 so that R2 becomes the higher priority ingress point for AS 100. Now, we have to remember as well that the lower the MED value, the more preferred the route. So it's important to note as well that unlike local preference, which does influence internal or can affect internal routing, the MEDs only influence the inbound traffic. So let's have a look at a basic MED or multi-exit discriminator configuration example. So it's a very simple policy example for the MED, as we've just said. So the first thing we're going to do is we're going to create the policy that will set a MED value of 50 on R1 so that the routes utilize R2. So we do a set policy options, policy statement, set MED, which is the name, term, again a name, prefer link to, from route filter 1010, 1010, 32 exact. So what we're stating here is we're stating this is only going to affect any traffic destined for this particular address. Okay. We then set the metric to 50 for that particular route and we then accept it. Okay, so what we're going to do now is in the secondary point, we apply the policy to the BGP neighbor. Okay, but we want to apply this policy within the router 1 BGP group. And the reason being is what we're basically saying here is we're saying we want the metric to be 50 for this particular route on router 1. So, as we state here, the above configuration will route traffic destined for the 1010 prefix to the lower MED link. So in this case, the lower MED link will be linked to, as it will still be a default MED of 0. Because as we've said here, on link 1, we want to set the metric to 50, and it'll prefer the lower MED, remember? So we'll see this in action in a minute, and it'll probably make more sense to you then, okay? So we're going to go and have a look at the topology now that we're going to use on the live demonstration. Okay, here's the topology we're going to utilize for this live demonstration. So we'll leave it there for a few seconds, but you can obviously pause the video here to get the information from this topology. We're going to show you the routing decisions made from the internet host through to the web server, and it'll be in AS100 that we'll see the changes taking place between R1 and R2 when we export the MEDs to R3 to influence that routing decision into AS100. Here we are at the live configuration screen. So what we'll do is we'll just quickly go through the configs first. Well, we won't actually go through them. I'll show you them. You can pause it if you want to have a look at them and copy them. So we've got the web server, which was on the left-hand side. There's the config for the web server. We've got router 0, which is in Autonomous System 120. That's connected to the web server. This is then connected to router 2 and router 1. So there's router 2 in AS100, as it states there. There's router 1, which is in AS100. Router 3, which is in AS110, which is connected to the internet host on the right-hand side. And as we know, the web server's loopback address is 1010.10.10. So this is what we're going to try and affect, is the route to 1010.10.10 from the internet host. So the first thing we've got to do is, can we ping that address? So let's ping 10.10.10.10. Yes, we can. So now let's do a trace route to it so that we can show you the route that it's taking. So that's the route it's taking. So we know 1.2 is going to be router 3. So the question is 1.6 router 1 or router 2? Well, 1.6 doesn't appear on here, so it's got to be router 2. So let's have a look at router 2, and there we go, 1.6. What's the next hop after 1.6, which is here? 1.18, which will be router 0. It has to be. And there we go. There it is there. Router 0. And then obviously 10.10.10.10 at the far end. Now, if we go to router 3 and we do a show route, this is a troubleshooting step that you can also use, but it's also a confirmation one. So if we do show route and the exact route we want to look at, so here it's 10.10.10.10, and we do a detail, it will show us both the BGP hops, but as you can see, the router ID, look, it chooses 1.6 above 1.10 because we have set no other attributes, so it goes to the lowest router ID, and we can see all the attributes on here as well, all the important ones. Okay, so how do we affect this BGP starred route, which is the preferred route, and allow it to be this route instead? Okay, so what we need to do is we need to go to the router that the route is currently traversing, and we know it is router 2. Let's go back to router 2. There it is, 192.168.1.6. So what we're going to do is on this router, we're going to go to edit mode, and we're not going to do it for that particular route. We'll do it for all routes, this change. So we're going to set our policy first. So policy options, policy statement, and we're going to call this one set MED. You can call it whatever you want, it's just a word, the same as the term is, but what we're going to do here is we'll say prefer link 1 because we're on router 2. So we're going to say prefer, actually let's call it prefer router 1, and we're going to set the metric for it. So the metric we'll set to 50. Remember the default is 0, so we're going to set it to 50, which will make it higher than router 1. And the metric works in the sense that from a MED perspective, it will pick the lower metric. So it should pick router 1 once we've completed this. So this will be for all routes. Then we can use the up arrow and we just do a then accept. So we can then accept this. We can commit that for the moment because there's something I want to point out here. So when we do a set protocols, which is the second part, is setting it within the group, and we do group and we want to router 3. That's the neighbor that we're going to export this to. So we do R3 and we do export set MED, which is the policy we've just created, and it's called set MED. But we will have a slight issue with regards to this. So if we commit this again and we go back to router 3, theoretically this should have changed and this route here should now appear up here, but it won't. So we'll have a look, and there we go, it stays as it is. Now the question is, why does it do that? So again, it's a good troubleshooting perspective here. We go back to router 2, we have a look at what we've just done. So if we have a look at the configuration again now, so we do a run show configuration and we do it as a display set. So what we've got is we've got in router 3, we actually export this policy before we export this one. So what does this policy state? Oh, it states from protocol static, then accept, protocol direct accept, anything else reject. So because that reject is in there, anything below this will be ignored. It just won't even look at this, any of these other policies that are below it. So we could use the move above statement, but I'm going to do it in a slightly quicker way. So if I delete this one, this export static local, okay, and then I commit that, and then I set it again, it will be set below the set MED this time. So we'll commit that and we'll have a look at it again, the configuration, so that you can see what's happened. Okay, so now we have the set MED above, so it'll go through this set MED one first here before it goes through this one. Okay, so now we've got it the right way round. Now if we go to router 3, remember, look, our router ID here was 10 for the rejected, or for the least preferred, and for the preferred it was 1.6. So now let's have a look at what we have now. Okay, now we have the preferred as 1.10 and the least preferred as 1.6, okay, because the MED comes before the RID. So what we have to do again though is we have to say, can we still ping that host? Yes, we can. The question is now, are we utilizing the new route? Remember, this was the trace route originally. So we need to see what we are looking at this time. So 1.2 is correct. 1.10, you notice now we're using 1.10, not 1.6. So we're actually going via router 1. This is how we can use the MEDs when we export. If we had control of AS110 where router 3 is, we could use an import using the same policy but importing it to state don't use router 2. But the chances of us having control of an upstream or downstream AS as well is highly unlikely. So that concludes the live configuration demonstration. Let's go back to the presentation and we'll do the summary and close screens. Let's summarize what we've learned about the MEDs, about the multi-exit discriminators. So The MEDs are an optional non-transitive attribute. What that means is it doesn't have to be included in BGP updates. It's not propagated from AS to AS. That means it's only locally significant to the ASs involved in the exchange. And in the example we utilised, as you know, that was router 3 that was in AS 110 and router 2 that was in AS 100. The MEDs are only exchanged between eBGP peers and they have zero meaning as far as iBGP peering goes. MEDs are an attribute that can be used to influence incoming traffic and it doesn't affect the internal routing of the AS, unlike the local preference. So it's also important to understand that we may be exporting this MED for incoming traffic, but we can only control what's ours. What I mean by that is that the upstream or downstream AS is more than likely another ISP and we have no control over it. So if we want to send an export policy telling those upstream or downstream ISPs where to send traffic, it could be that they have something that overwrites that. So it's good for us to talk to those ISPs to ensure that what we want them to do, they actually do for us. So as always, if you like this video and the channel content, then please subscribe. It would be great if you do, and you'll also have early access to new videos. Until next time, take care. And if you have any questions, let me know in the comments. Bye-bye.